Now given this problem statement, so here set S is given as, so this set contains the element alpha, and this alpha is constrained by this equation, that is log of base 2, and in the argument we are having 9 to the power 2 times alpha minus 4 plus 13 minus log of base 2, and here 5 over 2 times 3 to the power 2 alpha minus 4 plus 1, that is equal to 2. So that means only those values of alpha is acceptable in this set where it has to follow this particular equation. On solving this equation, whatever values of acceptable values of alpha will be there, that will be present in this particular set, right? Then we need to compute the maximum value of beta for which this equation has real roots, and the equation is x square minus 2 times summation of alpha, where alpha takes the value from set S, and this is squared over here, times x, plus summation where alpha takes the value from each value from set S, this is given as alpha plus 1 whole squared times beta. This equation has real roots, so we need to compute the maximum value of beta over here, right? So now I'll proceed towards the solution. So first of all, I will consider the equation which is presented in set S. Now this is the equation. Now let us proceed towards the solution for this one. Now we know this property that whenever log has the base is same, so here log base 2 and here also log base 2. So from this we can convert this difference, that is negative, here negative, this difference, the difference to division form, right? So here the next logarithmic factor argument, that is equal to 2 in this case, right? Now I will convert this logarithmic form to exponential form. So this factor will be equal to 2 square, that is in turn 4. Now here I'll make some simple assumptions. So I'll consider, let us make assumption that let, so let me make assumption here, let t, let this variable t represents this quantity, that is 3 to the power 2 alpha minus 4, right? Because this 9 can be written in 3 square form, so I can represent that one as well in the form of t, right? So now if I take this one, so this 9 to the power 2 alpha minus 4, so this can be written as t squared, and this one can be written as simply as t. Now on resolving this equation, I'll be getting here t square, and then minus 10 times t plus 9, that is equal to 0. Now I have a quadratic equation, so resolving these two quadratic factors, so this can be written as t minus 1 times t minus 9, that is equal to 0. So the acceptable values of t will be 1 and 9. So case to case I'll be solving this individually, right? So here I can say that when the value of t is equal to 1, so from this we can write that 1 is equal to, so this is t, and this t has been taken considered as 3 to the power 2 alpha minus 4. So from this I need to isolate the value of alpha. So from this we can clearly observe this 1 can be written as 3 to the power 0, right? Instead of 1 I can write this one as 3 to the power 0, and you can check clearly that 2 times alpha minus 4 is equal to 0, and on solving this alpha is clearly equal to 2. This is for the first situation, right? So when my t is equal to 9, now let me solve for the value of 9, right? So here this 9 can be written as 3 squared, that means 2 alpha minus 4, this will be equal to 2 over here, right? So here on adding 4, so 4 plus 2 is 6, so alpha will be definitely be 3, right? Alpha will be 3. Now from this we can say clearly that S belongs to, S contains the elements 2 and 3, because these 2 and 3 are the acceptable values, right? So now this part is taken care of. Now proceeding ahead with the next equation. So let me just arrange it a little bit. Now I will proceed with the next given equation, that is this one. So I'll just replicate this one, and in this one I can definitely write now, let me just replicate this, and instead of this part I can write definitely 2 plus 3. So for this alpha, from this alpha belongs to set S, so first of all I need to pick up 2, and then I need to pick up 3. Then for the next one, for this one, I need to pick up these values, that is 2 plus 1 whole squared, right, plus, and then here plus 3 plus 1 whole squared. Why? Because this summation, if you observe, this alpha takes the value from the set S. So first of all, I'll take 2, so this will be 2 plus 1 whole squared, and then it will take 3, so that is 3 plus 1 whole squared. Now I have the numbers clearly in front of me, so from this one I can write this one as x square minus, this will be 2 3s 5, and 5 square is 25, 25 times 2 is 50, 50 times x, right, and on resolving this one I'll be getting here 25 beta, right. So 3 square plus 16, so 9 plus 16, that is 25, so 25 times beta. Now it says that this equation will have real roots, this equation has real roots, it is already mentioned here, right. So this, it has real roots, so from this we can definitely say that b square, that is minus 50 whole squared, b square minus 4 times ac, so my a is 1 and c is 25 times beta, right, that is equal to 0. Now on resolving this one, minus 50 square, it is actually minus 50 square, so 2500 minus 100 beta, that has to be greater than equal to 0. So 2500 and then 100 times beta, this has to be, so I should write here greater than or equal to 0, greater than or equal to 0, right. So from this we can clearly observe, I can clearly observe that beta has to be less than equal to 25. So the maximum value of beta, so I can say that this beta max, the maximum value that is acceptable is 25, and hence 25 is the answer to this problem statement. And this, I'm writing this one as greater than 0 because it is very clear, the equation has real roots, so it is already mentioned in the problem statement, right, and hence we got 25 as the answer to this problem statement.